You'll be working on Delta Math today. I'm no good at calling the shots on these things. I could look at this and say it should take 10 minutes. I never know because I'm long-winded and teaching math takes time. So the goal here today is to just give you a quick lowdown on how to do this. And your experience already will help you with like the hardest part is finding the least common denominator. And from what I've seen on your quizzes so far, you're already pretty adept at that. So we're solving equations, they're rational. We are not going to spend a week on this. We're going to spend a couple days, kind of get in, get out. It's very quick, very simple. Might be just a mild, quick quiz on it, and that's it. Okay. So a rational equation is one that has fractions with variables in the bottom. Okay. So just to be clear, don't write this down like back in algebra one, 3/4 of x plus 5 equals 2. That's not a rational equation. Okay. It just happens to be a linear equation that contains a fraction. So in order for something to be defined as rational, it has to have the variable in the denominator. So our first example is this one, 1 over x squared plus x minus 6 minus 2 over x plus 3 equals 2 over x squared plus x minus 6. What you're going to find today, a little bit of a mixture, I think, at least in the lecture. I can't say specifically because Delta Math will generate problems that are beyond my control. But in this, you'll see a sampling of some of the equations that we're going to pop out are going to be linear and some of them are going to be quadratics. So you'll see. But in this first one, let's just see where the problem takes us. What do we do first? What do you think? Absolutely. And so that theme really just doesn't go away. Whether it's solving equations or adding and subtracting, you got to know how to find an LCD. So obviously we want to factor. This one on the left is going to factor into x plus 3 times x minus 2. And this one on the right is the same. So he's also x plus 3, x minus 2. And then you should be able to see with clarity what the LCD is. The LCD is the red thing, right? And so I go through now. What I'm going to do is I'm going to treat every one of these, please stop. I'm going to treat every one of these the same in that I'm just going to simply say, what does your bottom not have that it needs to make the LCD? It's kind of the same way we approach the addition and subtraction, right? The goal here is just operation, make the bottoms the same. So what does the first fraction need? Nothing, right? He's already got the LCD. So I'm just going to write down 1 and then I'm going to put minus 2. So if I'm progressing like, a computer, like a loading bar across the bottom of your screen, I have loaded this far. I'm right there, right? And what I need to do now is look at the second fraction and say, what are you missing? What's his bottom missing? He's missing the x minus 2. So I'm going to take that minus 2 and I'm going to multiply it by what its bottom is missing, which is x minus 2. Is this feeling sort of familiar? I'm assuming. And now my progress bar is going to continue on to the right, and I'm going to put equals 2. And what does the third fraction need? Nothing. So here's a fancy fun fact for you in mathematics. In this, I really need you I want you to hear everything, but I want you to hear this a lot. With equations, if you have the bottoms all the same, the bottoms don't matter. Let's say that again. The bottoms don't matter. Provided that you can make a match, they don't matter. So as I sit here, like if this were an adding and subtracting problem, then I wouldn't dare do what I'm about to do. But because I've now made the bottoms all the same, this is the math problem that results. The bottoms don't matter. So like if I had a simple situation, I wouldn't write this because you'll probably look back at it someday and go, what does that even mean? But if I had like x over a triangle minus 3 over triangle equals 10 over triangle. Yeah, I mean, x equals 13 because it doesn't matter what triangle is. The fact that all of these fractions have the same bottom, triangle, triangle, and triangle, the bottoms effectively fall away, leaving you with this, a sixth grade equation. Add 3 to both sides, x equals 13. You're done. Did that come out correctly? So make the bottoms the same and then pick them to the curb. So all we have to do now is solve that little baby equation that's up there written in red and white. What would you do first? Blast from the past. Yeah, I would take either answer. You could move the one to the other side or you could distribute, right? Doesn't really matter. So I'm just going to kind of leave the one and then I'm going to distribute the -2. What do I get? So I get -2x plus 4 equals 2. And then from here, it's like the thousandth equation you've solved probably. I would combine my 1 and my 4 to get 5. Bless you. And then I would subtract that 5 to the other side. I can do that much math at a class like this, right? So I have -2x equals, and then 2 minus 5 is -3. What does x equal? Rent. Now, because we're dealing in the land of rationals, we have to consider the idea of division by zero. It's going to be the hot theme for the day is, did I make a zero in the bottom of a fraction? So what we have to do is we don't have to go heavy on the math, but what we want to do is take our candidate, the guy that says, I want to be your answer, but you better make sure I'm not going to, anger the math gods. And we're going to go back to the beginning and we're going to put 3 halves up into all of these yellow circles. And what you want to make sure of, and I'm telling you this again, and if I ever have to walk this back and eat these words, I will. This step isn't so much about checking to see if the math all works as it was before. It's about, does the bottom equal 0? Thou shalt not divide by 0. I think it's number 1 in the 10 Commandments. Thou shalt not divide by 0. So if you put 3 halves up in here, this one will not equal 0. And this one will obviously not equal 0. Therefore, I can take my answer 3 halves and I can give it a box. Much like before with equations, your answers should never just sit out there buck naked. They should have a committed statement at the end. A box means I've tested it and you're good. A cross out means I've tested it and it makes a bad thing happen. Okay. So no answer at this point is complete until we mark it, so to speak. All right. So let's do a couple more. So our next one is going to be 1 over x equals 6 over x minus 2 plus 1. And again, why is it a rational equation? Because the thingamajig is in the bottom, right? So again, it's not just having a fraction. It's if there's a thingamajig in the bottom of the fraction, then that's when you know you're in the land of rationals. What do you think the LCD is? That the answer of doom, the answer that tells me that we still need to go back in time and work is, listen carefully. If you think the LCD is x minus 2, then you've got a real big issue we need to solve. I need to say this again. This x that I've marked with a red check mark and this x that I've marked with a green, they cannot work. They don't cover each other. The X with the red is like, I'm part of something. I'm not just a naked X flying around. I'm an X minus 2. I'm part of something. And so they don't cover each other. So the LCD is not X minus 2. It is X times X minus 2. Got it? And that's huge. If I can get you all over that hurdle, that's a big one, is to be able to see how those don't cover each other. So having said that, let's go ahead and take this 1 and let's make it a fraction of 1 over 1, and let's just do what we do. The goal is, again, operation make the bottoms the same, and we make the bottoms the same so that we don't even need to talk about them anymore. Because if the bottoms are the same, we just make an equation out of the tops. What is the first fraction missing? Yeah, his bottom has the x, but it doesn't have the x minus 2. So we need to take that 1 and multiply it by x minus 2. What is the second fraction's bottom missing? It is. So we're going to have to take that 6 and we're going to have to multiply it by x. And what is the third fraction's bottom missing?
Everything.
Everything. And I don't know if you heard Sutter say it a while ago, but a better way in this case to write it, just to save ourselves some time down the road, would be, instead of writing it disjointed like the green thing, to just keep it clean and quick and just write it as x squared minus 2x. Because you're going to have to multiply it out anyways. You might as well do it now. So are we all on board with the fact that the bottoms now match? I didn't show it, but we get that the tops happen because the bottoms happened, right? So at this point, the bottoms no longer matter, and I'm going to create an equation, and it's going to say x minus 2 equals 6x plus x squared minus 2x. Bottoms are gone. So the lesson kind of morphs from a lesson on rational equations now into a review on quadratic equations. And so let's put on our way back machine boots. How do you solve that equation?
Get the x minus 2 to the other side. Right.
Yeah, I mean, move all your stuff to one side. And you should be prioritizing putting everything on the side where that big man is positive, right? We've heard this before. So I'm going to leave my x squared here. This 6x and this minus 2x make 4x. And then if I bring the other x across, I'm down to 3x. And then if I bring the 2 across, I'm up to plus 2. And that's how a quadratic should look. Quadratics 101. Can we factor this? 2 and 1 for the win. So let's, I mean, there's other ways you could do it, but why not? Factoring is so quick. So let's do x plus 1 times x plus 2 equals 0. What are my, not my solutions, remember, what are my candidates? Those are my factors. What are my candidates? X equals -1 and x equals -2. Notice they're naked right now. They're out there in the open. I got to take them for a spin and see if anything bad happens. So we're going to take them, we're going to sail them back up to the beginning of the problem when there were variable denominators way up here, and we're going to go see if anything bad happens, okay? So if I can put these numbers one at a time in and something bad happens on the bottom, then I know that I've got a problem, right? So one of my answers is -1. If I put -1 where this is, that's fine. If I put -1 here, it's fine. And there's no variables in this denominator. So I believe that -1 can have a box. And I'm sure you're long ahead of my long-winded self by now. Yeah, I'm sure you've already checked -2 and you've come to the conclusion that it also poses no problems, right? So no zeros in the bottoms to me is we're good to go. 2 boxes. Okay. Let's go again, round 3. So we have x minus 5. You feeling good on this? Easy, right?
Yeah.
Taking longer than I want as always, but that's the nature of the beast. The key here is factoring, as it always has been. So before we can really answer the question intelligently about what do we have, what are we missing, we should factor. So it's nice that these two are the same. So let's just pick one like that one. How do you factor that down? What's the method? GCF. Good for you. Good. It's all those years of acquired just practice and knowledge. You just look at it and go, I got to pull out x squared. Nice job. And that leaves me with x minus 2, right? Mm-hmm. So I view this now and I say, okay, the component pieces of that, like I could even, if I wanted to go a little more over the top with showing work, I could show the x squared as x times x. And if we're talking about the Lego bag analogy or the box of parts or whatever that thing was I said a while back, I need 3 parts to build the most lost denominator there is, right? I need an x, I need another x, and I need an x minus 2. So we would agree that that's the LCD. So what is the first fraction missing? Nothing. So I can just take the x minus 5 and copy it down. And then I can put plus 3. And I'm in a waiting pattern right now. Got to see if I need to multiply. What does the second fraction need?
X minus 2. Wait, sorry.
He needs nothing, right? And then you got a little bit ahead of me there. And then if I go to the other side and I have equals 1, I normally wouldn't put a 1 here, but just to make a point. And he's missing some stuff. So what is he missing? He's yes. And so again, Sutter's kind of calculating things as we go, but just for the masses here, I just want to make sure we all understand. When you think about these 3 pieces in the LCD, this fraction, I'm going to circle him. He has one of the 3 pieces already, right? Mm-hmm. But he is missing the ones I'm putting in a green box. We agree. Mm-hmm. And so again, when you hear Sutter answering questions, he's just kind of I like it. Just kind of jumping ahead and saying he's missing the x and the x minus 2. So why don't we just cut to the chase and just call it x squared minus 2x? Good. And that's it. That accomplishes the operation, make the bottoms the same. And at this point, you realize that the parentheses are not necessary. And we just roll on. Just scroll all this off my screen, and now we just solve. We go algebra mode. So we leave the x squared. How many x's are we going to have?
Oh, one.
What'd you say?
Negative. Three. Negative.
It's like you're trying to crush my soul. Here we are. We're not changing things signs when we move them across the equal sign. In the my constant term is +2. And now it's time to factor. This factors into x minus 1 times x minus 2. Keep your equals 0 and then state your candidates. And the candidates are x equals 1 and x equals 2. Okay. So our job now is, before we box them or mark them or box them or cross them, is to go back up to the top and let's take them for a spin. So we have 1 and 2. So if we have, I think we're going to be in the clear again. I did not anticipate when I conjured up these problems that we'd keep getting this. There are going to be problems. Oh, is he bad?
Yeah.
Oh, you're right. He is. We found a bad guy. Whew, I thought I found some good ones, and I was like, what is, thank you. Yes. So if you put 1 in, 1's fine, right? Because you don't get 0 anywhere, but thank you. If you put 2 here, you get 8. And if you put 2 here, you get 4, and 2 times 4 is 8, and 8 minus 8 is 0. Thank you. So we figured out that 2's a bad guy. So what we're going to do with our candidates is we're going to give 1 this beautiful reward and say, you, sir, are a solution. And we're going to give 2 this dressing and say, you, sir, are no bueno. And I do have one more, and I don't remember why this one made the note card, but there must have been a reason. So let's do one more and then I'll shut up. Okay. All right. So this is, and you'll be working in Delta Math today. And what I found when I clicked through a bunch of the problems is, like, some of them have reject answers, like the cross out ones, and some of them just don't. So it'll be like a mixed bag for you. What are we doing first? Let's factor for sure. I mean, there's other answers. You could have told me, like, write 1 is 1/1, and I'd have been cool with that. But really what we're going to do is attack that first fraction. What is his factored version, his bottom? X times x minus 3. And now I'm going to take this 1 and just, because I like it, I'm just going to put 1/1. You certainly don't have to do that. It just helps to kind of see toppy bottomy thing. And we do what we've done 100 times before. We run through left to right and just keep asking, what are you missing? What can I give you? What are you missing? What can I give you? What is the first fraction missing? Nada. So we're just going to copy down the top, x squared minus 9x plus 20. What is the first thing after the equal sign missing? Everything. Good answer. So again, there would be really no sense in writing it as x times x minus 3. You might as well just write it as x squared minus 3x. Why make a math problem that you know you're going to have to turn around and do in a second anyways, right? What's the last thing missing? It's the x, right? So that's going to be a minus 1 times x, which is just going to look like that. I hope this is sufficient, because this is my last example. So I hope at this point you feel good. What kind of equation is this going to be? Quadratic or linear? How do you know that? They are. Yeah, good. So even though it kind of wants to, it's like a wannabe quadratic, it actually turns out that it's linear. So linear equations produce one solution. So we'll only have one thing to check. The x squareds, when you try to bring them together, they cancel. Oh God, let's try this again. How many x's on which side? So you want them on the left, -6? I'll take that. Good. So Andy's committed us to the variables are going to go on the left. The numbers have to go on the right. No, I appreciate you. Just dive in and do it. So what are we going to have on the right? Oh, that's not right, is it? No, that shouldn't be -6x. If you put these together, those make -4x. And if we add 4x, we should have -5x. Equals what? -20. But I mean, this is not, you took algebra from me, you took algebra 2 from me. You know how I feel about this. X's can go on either side. No one cares. So you just make a commitment and stick with it, right? So what does X equal? 4. And then you just go back and check, is 4 going to pose any problems for us? No. Over here, this is going to be 16 minus 12. We're good. This one's going to be 1. We're good. So you can take that answer and give it a box. When you do this in Delta Math, remember that if you have 2 answers that you want to hit, listen, you either want to hit the little button that says add additional answer, or you can hit comma and it'll bring up a second answer box. Got it?
Yes, sir.
All right. Any questions at all? All right. It's waiting for you on the old Delta Math, and I'm going to try to grind out the rest of your quizzes. No promises.
Ye,